Hi, it's Moser with a quick tutorial on molecular compounds, naming and writing formulas. After this video, you should be able to name any molecular compound when you're given the formula, as well as writing the formula for any molecular compound when given the name. You already need to know what molecules are, and being able to count to 10 is very helpful. So you remember these things. These are molecules. They're covalently bonded and they're discrete units, and we've talked about intermolecular forces and we've done Lewis diagrams. Well, now let's attach some names to these things. So as we already said, they are covalently bonded atoms, and what you need to know is that up until now you have been using the system for naming ionic compounds. The system for naming molecular compounds is a little bit different because partly there are some differences in what an ionic formula and a molecular formula represent. Remember that a molecular formula represents the actual number of atoms of each type that are in the compound. Well, in an ionic formula, we're just looking at a ratio. Now, there are even two systems for naming molecular compounds. The older system, which we're going to focus on, uses prefixes. So CCl4 is carbon tetrachloride. The newer system is the stock system, and that uses Roman numerals to indicate oxidation numbers and by default how many of each atom there are. As far as I know, it's still not as widely used, so we will focus on the older system, the prefix system. However, once you've learned oxidation numbers, we'll take a look at the newer stock system for molecular compounds. Well, let's jump right in. The rules are pretty simple. The less electronegative element comes first. You don't have to consult a table of electronegativities to do this. You can just remember your general trends. Electronegativity increases as we go across a period. So fluorine is more electronegative and oxygen is more electronegative than nitrogen. And electronegativity decreases as we go down a group. So chlorine is less electronegative than fluorine and sulfur is less electronegative than oxygen. That'll be important. Just remember that. Another way to think of this is to consider that the one that would be more likely to form a cation is the one that goes first, which kind of echoes what we've done with ionic compounds, that our cations always go first. Now, the second element is named, in the first element, we give a prefix if there's more than one atom of the stuff present. So we use di, tri, tetra, penta, hexa, hepta, octa, nona, deca. We don't use mono ever with the first one because just saying nitrogen tells us that there is at least one atom of nitrogen. The second element gets a prefix that indicates the number of atoms present, and we change the end of the name to an IDE, just like we did for the anions. Well, let's practice. We've got SF6, and we only have one sulfur atom. So I know that this is sulfur something. I'll need a prefix on the fluoride, and if I look, the prefix for 6 is hexa. This is sulfur hexafluoride. Again, I've only got one atom in the front position, so I just write carbon. I know it's something oxide, and if I refer to my prefix list, I quickly realize that this is carbon dioxide. You already knew that. This stuff, well, it's called water. Yes, but what's the chemical name for it? So here's one where we do have two atoms of our less electronegative element. So this would be dihydrogen. Now, this O is by itself and it's in the second position. We'll have to use the prefix mono, and when used with oxygen, we tend to just make that monoxide. We drop the leading or the remaining O in the mono and let the O in oxide take its place. This is dihydrogen monoxide. There's a pretty funny reading I'll share with you about the dangers of dihydrogen monoxide. Okay, we have here carbon, something, bromide. What's the prefix for 4 of anything? Well, if you've ever played Tetris where you line blocks up and there are 4 ways to turn each block, you might remember that it's tetra. Carbon tetrabromide. Ooh, this is a good one. So we've got 2 nitrogens and 5 oxygens. Because there is, in fact, a subscript on the first element in this compound, the nitrogen gets a prefix meaning 2, di-nitrogen, and there are 5 oxygens. So what's the prefix for 5? Penta. Just like we did with mono, when using penta with oxygen, we put pentoxide, dropping that extra A in there and letting the O sort of carry that syllable. Now, let's go the other way. So, when given a name for a molecular compound, you've got 2 jobs. The first is to identify the individual elements that are in it. Well, I have nitrogen, so that's going to be N, and there's going to be some subscript. The subscript is given by the prefix. So this is N2. Oops, I screwed up my name. That's better. We know that this is going to be oxygen of some sort, but what we want is the subscript, and that's again given by the prefix in the name. So this is going to be N2O3, dinitrogen trioxide. Okay, once again we have a molecular compound. I know that the first element here is carbon. What's my subscript? Well, there's no prefix on the carbon because carbon's in the first position. So the lack of a prefix means there's only 1 carbon. Same rule that we've used for ionic compounds applies, and we don't do a subscript if there's 1 of the atom. Tetrahydride. So the hydride throws people off, but hydride is just hydrogen with the gen replaced with ide. So this is C something H. What's the subscript on the H? Well, again, tetra means 4. So our final formula for this is CH4. It's methane. Oh, okay. Arsenic pentoxide. Well, arsenic, we know, is AS. What's the subscript? Well, what's the prefix? There is none, then the subscript is 1. Oxide means we're dealing with an oxygen atom here, and pent is penta with the A dropped because we're joining it with oxygen. So this would be ASO5 for our final formula. Sulfur trioxide. Well, sulfur obviously we know, and since there's no prefix, there's also no subscript. Now we have sulfur joined with oxygen, and our subscript comes from this prefix. So this is SO3. All right, do you feel like you can name any molecular compound when you're given the formula? Do you think that you can write the formula for any molecular compound when you're given the name? Excellent. Practice, FIP, keep working.